This is the second of 2 videos that I'm putting up here as a review of grade 10 factoring. So if you're watching this video, you should hopefully have already watched the first video or been in the lesson where we covered the basics of factoring. In this one, we're going to be going into more depth of how to deal with cases where we have a values on our polynomials when a is not 1 and it's not a common factor that we can take out. So let's go straight into that. If you had to factor something that looked like this, so 4x squared plus 11x plus 6. So your first instinct, anytime you're factoring, should always be to start by checking for common factors. Because if you can take anything out, you're going to make your polynomial smaller and you're going to make the factoring process easier. So we look at our constants here and our coefficients, so 4, 11, and 6. There's not much we can do there. We can't take out any variables because we don't have any x's in our third term. So no common factors, which means we move to our next step. What we're going to do now is, thinking back to the last video, remember you want to find 2 numbers that would multiply to your c and add to your b. But because we've got an a value here, we're going to have to change that a little bit. So instead of finding 2 numbers that multiply just to c, we're going to have to find 2 numbers that multiply to a times c. All right. So in this case, a times c, and remember this just comes from your standard form, so ax squared plus bx plus c. A and c are just our coefficients for our first and third term. So in this case, a times c is 24, right? 4 times 6. So we want to find 2 numbers that multiply to 24, but still add to the b value, which in this case is 11. And so some of you can probably just look at this and know what it is right away. Other people might need to make themselves a little list. So if we're thinking of the things that multiply to 24, well, it's 1 and 24, 2 and 12, 3 and 8, or 4 and 6. And so if we look at all those, the first pair is going to get you 25, the second pair is going to get you 14, the third one is going to get you 11, which is what we want, and the fourth pair is going to get you 10. So we want 3 and 8. And so if we were factoring this the way we would if there was no a value, we would just take those 2 numbers and we'd say, oh, hey, we're done. It's x plus 3 times x plus 8. But if you multiply that back out and you FOIL, you'll see that you get x squared plus 3x plus 8x plus 24, which, hey, we've got the 24. That seems okay. But when you simplify that, we get this, which is not the polynomial that we started with, right? We wanted 4x squared and 6, not x squared and 24. So something's gone wrong here. So we've got to change our methods slightly. So our next step isn't to go straight to our answer. It's to take those 2 numbers, the 3 and the 8, and use them to replace the 11. So we're going to use those 2 terms. So 3 and 8. And we're going to turn our 1x term into 2x terms. And this is really the step that tends to give people the most trouble because they just forget to do it. So our original polynomial, our 4x squared plus 11x plus 6, that 11 is now going to break apart. So the 4x squared is still going to be 4x squared. The 6 is still going to be a 6, but our 11x is now going to be an 8x and a 3x. Next step is pretty easy. You're going to take those 4 terms now and you're going to make them into 2 groups. So you're going to group the first 2 terms and the last 2 terms into just some pairs. Don't do this with brackets because it does tend to cause some mistakes. You can either just do it in your head or maybe with different color underlining or highlighting or whatever. Just some way to differentiate them to yourselves, whether it's on the page or just mentally. So for me, maybe I'll go with a red underline for those two terms and a blue underline for those two. Looking at those two groups now, we're going to take out common factors from each group. So if we look at 4x squared and 8x, so 4 and 8, we can take out a 4. And then x squared and x, they both have x's in them. So we're going to take out a 4 and an x. When we do that, remember when you take out common factors, you're just dividing. So 4x squared divided by 4x, the 4 is gone, and the x squared is now just an x. 8x divided by 4x is going to get me, well, 8 divided by 4 is 2, and then the x is just gone. So we got x plus 2. If we look at the other pair, 3 and 6, we're going to be able to take out a 3. And, well, that's about it. Which leaves me with this. So if you look at these two things, you should hopefully notice that both of the binomials that we've got in the brackets here are the same. And that actually has to happen. If these two things don't match, you've done something wrong and you've got to go back and try factoring again. Because our entire strategy hinges on those things being the same. So it might be you took out common factors wrong if they don't match. It might be that you picked the wrong numbers to break your middle term up. You go back and double check some things. Our last step here, because we're basically done, is we're going to take out that common factor, that thing that I just highlighted, the x plus 2's. So we're going to remove that as a common factor, and then we're just going to see what's left. So what we're essentially doing here, if I hop off to the side for a second, imagine you had something that was just 4xy plus 3y, and I asked you to take out common factors. And so you'd probably look at that and you'd say, well, 4 and 3, nothing going on there. Can't take out any x's, but they do both have a y. And so we could take out that y, and it would leave me with 4x plus 3. So that's exactly what we've got here. The only difference is that common factor isn't a y, it's an x plus 2, but we treat it the exact same way. So we're going to take out the x plus 2. And when we do that, it's going to leave behind 4x plus 3. And we can even color code that to kind of really show it. So you see the outside of the brackets here, we've got the 4x and the 3. And there we go, we have factored. That's it. It'll get a little bit easier or harder depending on the numbers, depending on the negatives, but the process should always be pretty well the same. You may also have your own different way of doing this that you've seen in a different class, maybe a tutor or Kumon or your parents or your siblings. That's fine. Whatever method works best for you is A-okay, as long as you understand it. So let's take a look at another example just to give it another shot. And we'll try factoring this one, 6x squared minus 11x plus 3. So if I look at those two things, I need two numbers that are going to multiply to 18, but add to negative 11. So I know I need either two positives or two negatives. In this case, it's going to be two negatives because I'm adding to a negative. And if I want to multiply to 18 and add to 11, that's going to be negative 9 and negative 2. Because I know those are going to get me negative 11 once I add them together. So we're going to take our middle term, which is 11 again, and we're going to break that 6x squared up into a 2x and a 9x. So it might look something like this. Remember, we're going to make some groups. So we're going to group up those first two terms and the last two terms. Notice how I underlined the negative. We'll talk about that in a sec. So from 6x squared and 9x, from 6 and 9, we can take out a 3, and we can also take out an x. And when we do that, it leaves behind 2x minus 3. If we look at our second set of terms, you might look at 2x and 3 and you say, well, okay, well, I can't take anything out. Right? 2 and 3, there's nothing in common. They both don't have x's, and that is true. There is no really useful factor that is common to these two things, but when you're doing this process, you do have to take out something. So if you can't take out anything tangible, you can always take out one of two numbers, either a positive one or a negative one. In this case, because that 2 at the front is a negative 2, or we're at least going to treat it as a negative 2, we're actually going to take out a negative 1. And when we do that, remember when you divide by a negative, everything switches. So our negative 2x is now going to be a positive 2x, and our positive 3 is now a negative 3. And so you can notice, again, that these two sets of brackets match. If we had just taken out a positive one, they wouldn't match with each other. So the key thing to remember is you can always take out either a 1 or a negative 1. Just whatever fits your situation. And so finishing it off, we've got that common factor of 2x minus 3. And then when we would get rid of those, we would have a 3x minus 1. You might be wondering what would happen if the 9 and the 2 had been written in a different order. It'll work out the exact same way. It'll just be slightly different stuff along the way. So we'll see what that would look like. So we've got 6x squared minus 2x minus 9x plus 3. And I actually personally, if I was doing the question, would probably have set it up this way. Because if you look at the numbers, the 6 and the 2 both go together fairly well, and the 9 and the 3 go together pretty well. Versus before, the first way we did this, 2 and 3 don't really mesh that nicely. So when I'm setting up my things, I always try to group things with stuff that has common factors, things that I know go together nicely. So if we make our groups here, the 6x and the 2x, we're going to be able to take out a 2x, which is going to leave behind 3x minus 1. The 9 and the 3, we're going to be able to take out a negative 3, which is also going to leave behind 3x minus 1. And so you might notice that we're basically ending up in the exact same spot. We've just come at it from the opposite side. So now the 3x minus 1 is our common factor, and we still get the 2x minus 3. The order of those two things makes no difference. Our answer is the same. All right, so time for you to try this one on your own. See how well you've gotten the hang of things. Be really careful with your negatives on this one. So 3y squared minus 13y minus 10. So think about how the negatives work. Give it your best shot. Come back in a minute. All right, so looking at this one, we wanted to find two numbers that multiplied to not just negative 10 and not just 30, but negative 30, and then add to negative 13. So multiplying to negative 30, you've got some options, 1 and 30, 2 and 15, 3 and 10, 5 and 6. There's two that really should stand out here. Because if you're trying to get a 13, you can get 13 from 10 and 3, and you can get 13 from 15 and 2. So you've really got to think about the negatives here. You're multiplying to negative 30, which means one of these numbers has to be negative and one of them has to be positive. We're adding to negative 13, which means we want to be adding more negatives. So our bigger number here should be negative, either negative 10 or negative 15. And so if you put those together, negative 10 plus 3 isn't going to get you negative 13, it's going to get you negative 7, which means that negative 15 plus 2 is the one that we want. So a really common place to mix this one up is just to not pay attention to your integers. All right, we go through our process. We break the negative 13 up into a negative 15 and a positive 2. And again, being thoughtful with our numbers, I'm probably going to put the 15 with the 3 so that the 2 can go with the 10. So we're going to have minus 15y plus 2y and minus 10. We make some pairs, and we take stuff out of those pairs, which is going to get me a 3y with a y minus 5 and a 2 with a y minus 5. And so finishing that off, our common factor of y minus 5 leaves us with 3y plus 2 as our other factor. All right, so that's how you handle an a value. The one other thing I wanted to touch on in this one is a special kind of polynomial that gets factored a slightly different way. You might remember having seen these in grade 10 because we did look at a couple of different kinds of what we call special polynomials or special factors. So this 4x squared minus 9, you could absolutely factor this normally. So if you're looking at this, if you're thinking of it in terms of ax squared plus bx plus c, this would be 4x squared, and then that 9 is the c, and then our middle term would actually just be 0x. We don't have any of them. And so you want to find things that would multiply to negative 36 and add to 0. And so you might think to yourself, okay, well, that's going to be plus 6x and then minus 6x. And then you can go through the whole process, but that's not actually the best way to factor this. This polynomial here is what we call a difference of squares. And these have a really predictable and easy way of factoring. Last year, you probably also would have seen perfect square polynomials. We're not going to focus on those too much because those we typically will just end up factoring the way they are most of the time because they don't stand out as easily. Differences of squares are really noticeable. Perfect squares a little bit less so. So the way a difference of squares work, if you have any square minus a different square, right? Difference meaning subtraction and squares meaning squares. So a squared minus b squared. Those will always factor the same way as a plus b times a minus b. So a and b being the square roots of your terms. If we have 4x squared and 9, so that's your a squared and your b squared, then a and b are the square roots of those two things. So the square root of 4x squared is 2x, and the square root of 9 is 3. So that's your b and your a. And so to factor this, 4x squared minus 9 is just 2x plus 3 times 2x minus 3. And then that's it. Done. Didn't even have to really put any work into it. If we tried another one, say 25x squared minus 64. So if I look at those two terms, 25 is going to get me 5. So it's going to be 5x. And then 64 gets me 8. So 5x minus 8. And then 5x plus 8. All right, so we're going to give you one more of these to try. So we've got negative 72 x to the power of 4 plus 200 y to the power of 8. So at first glance, this one should seem slightly off because 72 is not a perfect square and 200 is not a perfect square. So it doesn't seem like it would match a difference of squares. So take a minute on your own, see if you can figure out what's going on with this one and if you can factor it. If not, come back and continue the video. All right, so going back to the beginning of the lesson, I mentioned that the first thing you want to do when you're factoring is check for common factors, and that is the case here as well. So 72 and 200 are both divisible by a couple of things. You could just take out a 2 and it would make this work, but it won't get you the simplest answer. The best thing you could actually take out here would be an 8, but not just an 8, a negative 8, because we don't like having this negative on the 72. So when you take out that negative 8, we're going to end up with 9x to the power of 4 plus, minus, because we're taking out a negative, y to the power of 8. Right, and so if you didn't get this far and you want to try factoring this part on your own, go ahead, pause here and give it another shot. But if not, we're just going to keep going. So we've got negative 8, and then that 9x to the power of 4 minus 25y to the power of 8. The variables seem like they make things harder, but they don't really. 9 is just going to give us a 3. X to the power of 4. So if you're doing the square root with variables, if you had, say, x to the power of, 14, and you want to do the square root of that, that is just going to be half of the exponent. So this is just going to be x to the power of 7. Because remember, when you multiply things, x to the power of 7 times x to the power of 7 would add the variables, or add the exponents rather, and get you x to the power of 14. So to go backwards, you're basically just going to divide by 2. So this is going to get me 3x squared, and then 5y to the power of 4, because it's just half of 8. And then we'd get the exact same thing, but with a plus. And there you go. If you've watched both of these videos, you should be hopefully set with your factoring and ready to move on to actually using your factoring. So in the next part of this unit, we're going to see how to solve quadratic equations by using this factoring as a tool. If you need a little bit more help with this, feel free to go back into the Foundations in Pre-Calc 10 videos just to get a little bit more examples and a little bit more guidance on how to handle these things. Otherwise, move along to the next one.